Hello everyone. In today's lecture, we'll talk about the polynomials. We'll revise the same concept which we had learned in the previous session. We'll talk about what is polynomial, how we can recognize the polynomial, although we can categorize the polynomial, what is the name of the polynomial of degree of terms, two terms, three terms in more than three terms, and then we'll talk about the remainder theorem. So I'm going to share you a video. Here we'll understood what is the polynomial is.
Builds up, let's look at the concept of terms and expressions. 14xz plus 53y minus 3. There is a plus as well as a minus sign here, which means that we have three terms: 14xz, 53y, and 3. Second expression is 23x squared y minus 4y cubed. This expression has just two terms: 23x squared y and 4y cubed. Now we can move on to understanding the most important concept in algebraic expressions.
So if we have monomials and the monomials are combined with addition or subtraction sign, so this will be considered as the polynomial of two terms or three terms, or if it is a single term, it will be called it monomial. So we'll learn the names of polynomial now, but make sure that will be combined with positive or negative sign. If it is multiplication or division, it should not be a polynomial. It should not be considered as two or more than two terms. If I divide 4x cubed by x, 4x cubed by x, if I'm dividing 4x, if I'm writing 4x square by x, then on simplifying I'll get 4x square only. 4x cubed by x, I'll get 4x square only. So that will be a monomial only because it is combined with the division sign. If I write 4x into x, that will be again 4x square. So on simplifying it, I'll get a monomial only. So the combination made up with positive or negative sign, that is addition or subtraction, will create a polynomial.
It's the concept of polynomials. As you can see, the word has been colored into two parts. Poly means many, and nomial means parts or terms in the case of algebraic expressions. And that's how the word polynomial comes about. There are different types of polynomials. A polynomial can be an expression with just one term, or two terms, or three terms, or maybe even a greater number of terms. All these categories come under one roof, which is the polynomial.
So polynomial can have one term, two term, three term, more than three term, higher number of terms, four terms, five terms, and so on. So all this considered as polynomial only. It is one term, two term, three term, four term. Though it is named differently, the one term.
Expressions with just one term, two terms, or three terms are given special names. An expression with one term is called monomial. An expression with two terms is called a binomial. And an expression that has three terms is called a trinomial. Mono is 1, bi is 2, and tri is 3.
So if it is one term, it is called monomial. If it is two terms, it is called binomial. If it is three terms, it's called trinomial. If it is more than three terms, there is four term, five term. Though the names are given as quadrinomial, pentanomial, but in simple way, we write it as and we call it as polynomial. So more than three terms, more than say four or five terms, or more than that, it is simplified as polynomial.
There is a common misconception that only an expression with more than three terms is called a polynomial. That's incorrect. All expressions which have one or more terms are called polynomials. Let's look at a few examples of each. The number 7 is a monomial. It's just one term. 4x is also a monomial. It's just one term as 4 and x are multiplied. Even 3ab squared is a monomial. And yes, all these expressions are also polynomials. An example of a binomial would be 4 plus x. The plus sign separates the terms. Another example would be 3xy minus x. An example of a trinomial would be 3 plus a plus b. It has three terms, 1, 2, and 3. Or maybe 3ct plus a plus 8. Again, let me remind you, all these examples you have seen are polynomials. And an example of the last type would be 4z plus 9 plus 3x plus y. It has 4 terms in all. So remember, a polynomial is an expression which has one or more terms.
So the polynomial is expression with one or more than one term. It is a one term. It is called monomial. The examples are 7, 4x, 3x, 3ab square, 100, 500, 3x square y, and so on. If you have two term, we can write it as 4 plus x, 3xy minus x, 4x plus y, 3y plus z. So if you have two terms combined with addition or subtraction, it is called binomial. It is three terms, 3 plus a plus b, 3ct plus a plus 8, or 4x square plus 3x plus 5, or 7x square plus 8y square plus 7z square. So this all are the three. If it has three terms, it's called trinomial. If it has four terms, say 4z plus 9 plus 3x plus y, or x plus y plus z plus 5. So if it is four terms, it is considered as polynomial with more than three terms, that is four terms, five terms. But it is also called quadranomial with four terms. So it also has a special name, but we consider it as a polynomial only. So the terms algebraic expression whose power is positive, that is the exponent of all the variables is a whole number, is called polynomial.
हेलो दोस्तों, वेलकम टू दिस प्रेजेंटेशन फ्रॉम राइजिंग फर्म। हम आपके होस्ट आपके दोस्त रॉय। आज दोस्तों सीरीज नंबर 2।
So here we'll talk about the remainder theorem now. What is remainder theorem is, see, we are going to learn the remainder theorem. In remainder theorem, if we are dividing a polynomial by another polynomial, if we are dividing a polynomial of degree 1 or more than 1, that is, we are taking a degree polynomial of degree 2 now, and by a polynomial, say px is divided by gx, where px is dividend, gx is divisor, we will get a quotient and a remainder. So when we divide px by gx, we'll get a quotient and a remainder. So we can write as, if we are dividing 101 by 3, then 101 is our px and 3 is gx. So 101 is px and gx is 3. That is dividend upon divisor. So this will help us to find out the remainder, which is remainder theorem. So we'll find out the remainder. If it is asked the remainder only, we'll apply the remainder theorem in the question. So whenever we divide a polynomial of degree 1 or more than 1 by a polynomial of degree 1, we'll get a quotient and a remainder. To get the remainder, we'll apply the remainder theorem. Now, if I'll consider a case or a question where we have a polynomial px such that the value of polynomial px is 2x square plus 7x and plus 6. So we have polynomial 2x square plus 7x plus 6, which is dividend, and it's to be divided by x minus 2. So we are dividing a polynomial by x minus 2. So first we'll divide it by the long division method, as we did in the previous class. We'll divide 2x square plus 7x plus 6 by x minus 2. 2x square plus 7x plus 6 by gx, that is gx is x minus 2. So we are dividing px by gx. So gx is x minus 2. We'll write the value of gx here, x minus 2. Alright. So we are trying to divide 2x square plus 7x plus 6 by x minus 2. To find out the first term of quotient, we will divide the first term of dividend by first term of divisor. That is 2x square by x. When we will divide 2x square by x, x and x will get cancelled and we will get the first term of quotient as 2x. The first term of this quotient will be 2x here. Now, this 2x multiplied by x will give you 2x square, and 2x multiplied by 2, 2x multiplied by minus 2 will give you minus 4x. If we need to subtract it, we need to change the sign of 2x square minus 4x. So this 2x square will become negative and minus 4x will become positive. Now 2x square minus 2x square will become 0. 4x plus 7x will give you 11x and plus 6. Now this 11x is the our new dividend. So first we'll divide the 11x by x, that is the first term of divisor by first term of dividend by first term of divisor. 11x by x will give you 11. The next term of quotient is 11. 11 into x, 11x, and 11 into minus 2 will give you minus 22. Then we'll change the sign. Minus 11x and plus 22. 11x minus 11x 0, and 6 plus 22 will give you 28. Here the 28 is remainder. See, the power or the degree of this 28 is, we can write 28 as 28x raised to power 0, and here the degree of this divisor is 1. So this x is nothing but x raised to power 1, and 28 is nothing but x raised to power 0. So we can write it as a 28 x raised to power 0, and here the power is 1. So make sure the remainder have the power less than the divisor. The degree of remainder should be less than the degree of divisor. So we got the quotient here by dividing the long division method as 2x plus 11, and remainder as 28x raised to power 0 here. So we got remainder is 28x to the power 0 and quotient is 22x plus 11. Now we'll talk about the remainder theorem. What is remainder theorem all about is, the remainder theorem will give you the remainder only. That is, let Px, this remainder theorem is, let Px be any polynomial of degree greater than or equals to 1, and let A be any real number. Degree must be greater than or equals to 1, and let A be any real number if Px is divided by a linear polynomial x minus a. If Px is divided by a linear polynomial x minus a, then the remainder is P of a. It must be a linear polynomial. Point to be noted. It must be a linear polynomial x minus a, and the remainder is P of a. This is called the remainder theorem. So once again, let Px be any polynomial of degree greater than or equals to 1, and let a be any real number. If Px is divided by a linear polynomial x minus a, then the remainder is P of a, x minus a. If you are dividing it by x minus a, then the remainder is P of a. This is what the remainder theorem is. So we'll consider it using an example. As per the remainder theorem, if you are dividing Px by Gx, and we'll get the remainder as P of a. So let's write it. P of a x minus a. We can find out the value of a as, if we equate x minus a with 0, then x is equals to a. We'll get the value in that case, in that way as well. So we are dividing Px, the same question we are taking, 2x square plus 7x plus 6, and Gx as x plus x minus 2, as we taken in the previous question. So we need to find the remainder. So when we divide Px by Gx, we'll get the remainder, and as per the remainder theorem, it will be P of a. That is, in this case, the value of a is 2. So we'll get the value of a as 2 here. So when we'll divide Px by Gx, there must be a remainder, and as per the remainder theorem, it must be P of 2. Why P of 2? Because when we will equate this x minus 2 with x minus a, here we can get the value of a as 2. So when we substitute the value of a as 2 in the given polynomial, we'll get P of 2 is equals to get the remainder, we'll apply the remainder theorem here, then we'll get the value of P of 2 as 2 into 2 square we'll substitute the value x is equals to 2 here, 2 into 2 square plus 7 into 2 plus 6. Now this 2 into 2 square is 4 and 4 2s are 8, 7 into 2 14 and plus 6. 14 plus 6 is 20 and 20 plus 8 is 28. So you can see the remainder is 28. The remainder is 28 here in this case using remainder theorem. And now you can see when we did the previous question by long division method, here also we'll get the remainder is 28 only. So if it is asked in the question to find out the remainder when the polynomial is divided by the another linear polynomial, we can apply the remainder theorem to find out the remainder without doing the actual division when the quotient is not asked in the question. If it is not asked in the question, we can directly apply the remainder theorem. This will solve your question within a couple of minutes only. So it is better to apply the remainder theorem if it is asked the remainder only. In the next class, we'll talk about the remainder theorem further, and then we'll talk about the question based on remainder theorem. We'll talk about the question based on the value of polynomial, and we'll identify the polynomial. That is, we'll discuss exercise 2.1, 2.2, and 2.3 in the next class. So here today we understood about the remainder theorem. Just try to solve a few questions of exercise 2.3 from your book. Thank you very much.